Welcome to YouTube channel scientific underscore math. We are solving a system of linear equations by LU decomposition using different techniques like Gauss elimination method, Doolittle method, Kraut's method, and Choleskys method. In previous lecture, we have discussed Gauss elimination method, Doolittle method, and Kraut's method, and we have also solved examples related to these methods. I will provide the link in video description. You can watch all these lectures. In this lecture, we will discuss Cholesky's method, how we can use the Cholesky's method to solve the system of linear equations, and then in next lecture we will solve example related to the Cholesky's method. Okay, so let's start. Cholesky's decomposition LTL transpose. Okay, so what is Cholesky's method? And we have Cholesky's decomposition is a method for solving a system of linear equations like Ax is equal to b. Okay, so in this method, for every symmetric positive definite and cross n coefficient matrix, okay, here we have a condition like for every symmetric positive definite matrix of order n cross n coefficient matrix, that is the matrix A we have, and is decomposed into the product of unique low triangular matrix L and its transpose. Okay, so here L is the low triangular matrix. Okay, so we decompose the coefficient matrix A into the product of low triangular matrix and the transpose of the low triangular matrix. Okay, that is L. Okay, so next L is the Cholesky factor of A and it can be interpreted as the generalized square root of the coefficient matrix A as described in the Cholesky decomposition. Okay, so we decompose the matrix A into the low triangular matrix and its transpose. Okay, so for n cross n matrix for we have a form like that. This is the A matrix, coefficient matrix A of order n cross n, and we decompose this matrix into the n cross n low triangular matrix and its transpose. This one is the transpose of the low triangular matrix. Okay, so for the case of uh, a system of three equations, the matrix of coefficient, that is A, is order of 3 cross 3, and the LU or the LTL transpose decomposition has the form. Okay, so this one we can also describe as the upper triangular matrix, which is equal to the transpose of the lower triangular matrix. Okay, so we have the coefficient matrix or the three for three equations. We have the coefficient matrix of order 3 cross 3, where we can see that we have 3 rows and 3 columns. Okay, we decomposed this coefficient matrix into the lower triangular matrix L and the transpose of the lower triangular matrix we have. Okay, so in this case we can see that here and the off diagonal elements in this case and the off diagonal elements in this case, both are same L21 L21 L31 L31 L32 and L32. So we will calculate only the low triangular, the off diagonal elements, that is below the diagonal. Okay, so we have the decomposition form of the coefficient matrix A like that. That is the low triangular matrix, and this one is the transpose of the low triangular matrix. Okay, so we multiply and these matrices with each other, and we have the form like that. Okay, so as uh, I have already said the off diagonal elements in this case both are same, so we will only calculate off diagonal elements that are below the diagonal. Okay, so now we can calculate the solution is obtained by equating the corresponding elements of the matrices. Okay, so we equate the elements of the matrices like that. L21, that is L11, sorry, square is equal to A11, and L2 L11 will be equal to the square root of the A11. Okay, so this will give us L11, and next we will equate in this one, and like L21 L11, which is equal to A21, and here we will calculate the L21 because we have already L11, and L21 will be equal to A21 divided by L11. Okay, so next we will calculate this this equation, and this equation will be L21 cos square plus L22 square, which will be equal to A2. Okay, here we will solve this equation for this one. Okay, and next we will solve this equation, and that is L31 L11 will be equal to A. Okay, so next for this one, and then for this. Okay, so we have, okay, this one. So, and this one is the L11, L21, L22, L31, L32, and the last one L33. Okay, so we can see that for the diagonal elements of the low triangular matrix, there is a calculation pattern like that. L11 is equal to the square root of A11, and L22 is equal to square root of A22 minus L21 square, and similarly for L33 is equal to square root of A33 minus L31 square plus L32 square. Okay, so or in general form we can write as the LKK is equal to square root of uh, AKK minus mission J is equal to 1 to K minus 1, and L square KJ. Okay, so this is the generalized form for the uh, diagonal elements, and we can change the value of over here KK. Okay, so for the off diagonal elements, there is also a calculation pattern like that. L21 that is equal to 1 by L11 and into A21, and L31 which is equal to 1 by L11 A31, and similarly for L32 this is equal to 1 by L22, and into A32 minus L31 into L21. Okay, so which can be expressed in general form like that. This one is the generalized form for the off diagonal elements of the matrix L. Okay, so here we have a node for that, Choleskys decomposition LTL transpose, and this one, and we in this technique, that is the LTL transpose decomposition only for the symmetric positive definite of order n cross n matrix. This means we can apply the Choleskys LTL transpose decomposition only when we have the given matrix is symmetric and positive definite matrix. How we can know the given matrix is positive definite matrix? We have already discussed about the positive definite matrix, and I will provide the link of in the lecture that is related to the positive definite matrix in the video description. You can watch. Okay, so thank you so much for watching my video. Please subscribe my channel scientific underscore math. In next lecture we will solve example related to the Choleskys decomposition.